welcome back to thinktankonlinelearning. So in this video, I want to prove some complex hyperbolic trigonometric functions. Okay, so we have some identities here. So I want to prove if Cosh z is equal to cos iz. So first of all, let's write what is cos z. So you know cos z is equal to e to the power iz plus e to the power negative iz divided by 2. Okay, and for Cosh z, let's write the identity for Cosh z. Cosh z, okay, just the same. The only thing that is going to change is that you no longer have some I here. Cos negative z divided by 2. Okay, so now it's time to prove it. So how are we going to prove it? Okay, I'm going to choose the side that we want. So I'm going to choose this side. Let me write here. Cosh z is equal to cos iz. Okay, and I'm going to take the left hand side. Okay, this is the right hand side. That is what I'm going to take. Okay, so cos iz is equal to, remember for cos z we have e to the power iz, so you're going to have e to the power I, and in this case our angle is iz, okay, plus e to the power negative I, and in this case the angle is also iz. We're going to divide this by 2. Okay, I times I, that's going to give us -1, so it's going to be e to the power negative iz negative z, right? And for this one, I times I -1, -1 times negative, it's going to give us positive z divided by 2. And if we arrange this, we'll see it's going to be e to the power z plus e to the power negative z divided by 2, and this one is identical to Cosh z, and we have proven it. Okay, so now let's move on to part 2. Okay, I'm just going to try to be here. So for part 2, what is the identity for sin z first of all? Okay, so for sin z, what do we have for sin z? We know that sin z is e to the power iz minus e to the power negative iz divided by 2i, right? And let's go to sin z. Sin z, okay, so for sin z, it's e to the power z minus e to the power negative z divided by 2, and don't have an I. Okay, so I want to prove the identity. Sin z is equal to, it's sin iz. Okay, let me write it here. I want to prove I. Let me put the I here. And here, what do I have? I have iz right here. Is identical to sin z. So I'm going to choose the left hand side. Okay, so we have I here. I sin iz is going to be equal to I. Okay, let me put a bracket here. And for sin z, see the identity for sin z. So now it's going to be e to the power I, and you're going to have iz here, since the angle has changed, minus e to the power negative I, and you're going to have iz here. And we're going to divide this by 2i. Okay, and if you want, you can just clear this one and this one, and what we are going to have, you're going to have negative I times I times I, that will give us positive, but we need, and we have a negative here, and for this one we're going to have a negative, right? So we're going to have e to the power negative z here, I and I, minus e to the power positive z here divided by 2. We needed a negative here, so let's just put a negative here. Need a negative here, you can just put it right here, and here we have a negative. Okay, let's write it like this. I think that will be good. Now let's distribute the negative. We're going to have e to the power z minus, this one's going to become positive, this one's going to become negative divided by 2. And as you can see, this one is now equal to this one, and this one is equal to shine Z, and it's proven. Part C. Okay, we have Cosh Z squared minus shine Z squared is identical to 1. Okay, let's use the left hand. Okay, I'm going to use the left hand to prove. Okay, so I'm going to use the left hand side. Okay, so for Cosh Z, what is Cosh Z? Cosh Z is e to the power Z plus e to the power negative Z over 2 squared, and we're going to subtract this one by Cosh Z. So for Cosh Z, I think I've written for shine Z, it's e to the power Z minus e to the power negative Z divided by 2. So now I'm going to expand. Okay, so for expanding this, I'm going to use this law: a squared minus b squared is equals to a plus b times a minus b. Okay, now what is a and what is b? Okay, so a is e to the power z plus e to the power negative z divided by 2, and b is equal to e to the power z minus e to the power negative z divided by 2. So by applying this, I'm going to have e to the power z plus e to the power negative z divided by 2. I'm going to add it with e to the power z minus e to the power negative z divided by 2. I'm going to multiply this one by b minus a minus b, e to the power negative z plus e to the power negative z over 2 minus e to the power z minus e to the power negative z divided by 2. Okay, and now it's time we expand. Okay, but since these two have common denominators, you can just add the numerators. It's e to the power z plus e to the power negative z plus e to the power z minus e to the power negative z divided by 2 right here. And for this one, it's e to the power z plus e to the power negative z minus e to the power z. It's going to be positive c. Minus and minus is going to be plus e to the power negative z divided by 2. Okay, 2 times 2, going to have 4 here on the denominator. Let's go on top. This one and this one, as you can see, this one. Okay, so here we have this one. So this one is supposed to be positive, right? This one's supposed to be positive minus this one. And as you can see, this one goes away with this one. So we're going to have this one plus this one. So it's going to be 2e to the power z times here e to the power negative z, e to the power z, e to the power z. This one got this one. And if we add these two together, we're going to have 2 to the power negative z. Okay, 2 times 2, we're going to have 4 over 1. 4 over 4, right? And for this one, it's e to the power z times e to the power negative z. And by laws of indices, this one is going to be 4 over 4 e to the power negative z plus z. That is going to be 4 over 4 times e to the power 0. That is going to give us 1. Thank you for watching. Don't forget to subscribe.